So the next problem in this segment is problem number 5.274, and the problem is stating illuminating the surface of a certain metal alternately with a light of wavelength 0.35 micrometer and then with 0.54 micrometer. It was found that the corresponding maximum velocities of the photoelectrons differ by a factor 2. Then find the work function of that metal. So if we understand this problem, so the problem is stating that we have a certain metal. So when this metal surface is illuminated by a light of certain wavelength, say lambda 1, then we write the expression for kinetic energy maximum as incident energy minus work function. So for the first scenario that we have, we write half m v square. So this is equal to incident energy hc by lambda 1 minus work function phi. Now in the second scenario, the same metal surface is illuminated with light of wavelength lambda 2. For this particular case, we can again write kinetic energy maximum is equal to incident energy minus work function. So this time the problem is stating that the wavelength lambda 2 is greater than lambda 1. So if wavelength is greater, the energy is reduced. So if incident energy is reduced, then the kinetic energy is also reduced, and it is stating by a factor 2. So by a factor 2, then I mean to say that v by 2 square, which is equal to hc by lambda 2 minus work function phi. So this one is equation number 1 that we have, and if we rewrite this, we can write it as half m v square by 4. So 4 we multiply on the other side, 4 times hc by lambda 2 minus 4 phi. This is the second equation that we have. So if we look at expression 1 and then we look at expression 2, then we can say both the expressions are equated to the same quantity, half mv square. So therefore we can write it as hc by lambda 1 minus phi equals 4 times hc by lambda 2 minus 4 phi. So we can write this one as hc 1 by lambda 1 minus 4 by lambda 2 is equal to, ठीक है, ये वाला बाद में फिर कर लेते हैं.